Okay, so the first thing we need to look at is static electricity. Now, to know anything about static electricity, you really have to think about something called charge. Now, charge is a fundamental property of all matter. It's something like mass or even things like colour. It's something you can describe something with. So as much as you can have a pink coat or a blue hat, everything has a charge. And that charge is either positive, negative, or charge neutral, which I'm going to do as a 0. Now, all charge comes really from 3 particles. Positive particles are called protons. The negative particles are called electrons. And the neutral particles are conveniently called neutrons. Now, whether something is positive or negative depends on how many protons and electrons they have. So something that's got lots and lots of protons and only a couple of electrons, like this, is overall positive. And that's how you can sometimes write it, because it's got more positive charges than negative charges. Something that's got lots of negative charges and only a couple of positive charges, so I'm sure you can see where this is going, is called negative. Because overall, it's got more negative charges. These two cancel each other out, these two cancel each other out, but there are 3 extra negative charges. Something that has got an equal number of positive and negative charges is called neutral. So this is neutral. Now, if I added in some neutrons, which I'm going to draw like this would not affect the charge of this object because neutrons haven't got a charge. So you need to think about protons, which are positive, and electrons, which are negative. Now, the main thing that we have protons, electrons, and neutrons in, or the only thing we have them in, are atoms. And as we know, everything is made up of atoms. So an atom has a particular structure. And I'm going to draw a helium atom because that's nice and easy to think about. A helium atom has got a nucleus, which has got 2 protons, and I've changed the colour of my protons now, I apologise. 2 protons and 2 neutrons, like this. It has 4 particles in its nucleus. Now, a nucleus is very tightly packed and is very dense and has all the positive charge in there. Okay, so the nucleus of the atom is the centre. Now, we know that atoms overall, generally, atoms are neutral. And to do that, we have to kind of balance out these 2 positive charges with electrons, and we do that by putting the electrons in orbit around the nucleus. So it's a bit like, I think, of the solar system, with the sun as the nucleus, and then the planets acting as the electrons. So for a helium atom, which this is, I'll write that there, we have 2 protons in the centre, 2 neutrons, but they don't affect the charge. So to balance out these 2 protons, we have 2 electrons orbiting. Now, in an atom, the protons are kind of really quite fixed. They can't really move. It's quite difficult to make them move. So the protons generally stay how they are. Electrons, however, are more loosely bound, we say. They're not as strongly attracted. So they can be moved a lot easier than the protons. And that's for reasons that you'll go on to an A-level called the strong force and the electrostatic force. But all you need to know is that protons can't really move, electrons can. And that is the whole point of static electricity. That's what happens in static electricity. Your electrons move and build up charge. Now, static electricity is just the build-up of charge. And because it's called static, that means that this charge stays still. Okay? It builds up and stays there. Now, the classic experiment that you might have done in your lessons is you have a plastic rod, which you then rub with a cloth. And after rubbing it, you can pick up little pieces of paper, or you can bend water. Now, to think about why that happens, we need to think about the charges. So a plastic rod, to start with, is neutral. It's got, I'm going to draw 5 protons and 5 electrons. And change colour again. Then, on my cloth, that's also neutral. I'm going to just draw 3 protons and 3 electrons. So this is before rubbing. Okay? They're both neutral. There's no net positive or negative charge, they're both neutral. Now, when we rub the rod with the cloth, something happens, okay? The electrons begin to move, the electrons begin to transfer to the cloth, like so. Now this means that my rod, which has been conveniently drawn before, still has 5 protons because protons can't move. It now has less electrons because they've moved over. My cloth still has 3 protons like before, but these extra 3 electrons from here have moved on. So we now have 6 electrons and 3 protons, 5 protons and 2 electrons here. So that means that now this rod has become positively charged because there are more protons than electrons. And that this cloth must have become negatively charged because there are more electrons than protons. Now, we can use this rod now to do some things and the cloth, but the rod kind of works better. So if I now draw my rod here, my positive rod, so overall it's positive by 3 electrons, I'm going to draw 3 pluses. If I hold that over something such as maybe a few little pieces of paper, here's my paper, we'll see that they start to jump up to here. And they're often attracted, not strongly, but weakly attracted. Now that's because these pieces of paper are also made of protons and neutrons and electrons. And the positive charge here attracts the negative electrons of the paper up to the top and then makes them jump up. So that it splits the negative and positive charges. The negatives are a little bit more attracted than the positives are, and they jump up to the rod up here. You can also see the same effect if you hold your rod near some water. Okay, so here's my water. And you should see that it bends that way. And that's because your positive charge on your rod here has attracted the negative parts of the H2O molecules, because water has got kind of, the way its charge is spread out, it's not even. So it attracts the negative parts of the water molecules towards it, and that makes the water molecule, that makes the water stream even bend. So that's the basics of static electricity. It's the build-up of positive charge or negative charge, and that's through the movement of electrons. So only electrons move. That's really important to know. Protons can't. And static electricity is just when electrons are moved, so there's more protons and electrons on one thing, more electrons and protons on the other thing. And that means that we've built up a static charge. These are both statically charged, one positively, one negatively. Now you may have seen something called a Van de Graaff generator in your lessons, which has got a big metal dome, a rubber belt like this, and that's inside a metal box. Now this is called a Van de Graaff generator. Van de spells something like this, I usually get this wrong. Van de Graaff generator. And this stores electric charge. It creates static electricity and stores it. Now what happens is that my electrons are transferred, there's a brush here, and that transfers electrons to the rubber belt, which then they move up here, so they're moving up here, and then there's another brush here which is connected to the metal dome, and the electrons are moved on, they transfer from the belt up through the brush, through the metal contact here, and then they collect on the dome. So on this dome there are lots and lots of negative charges. And they just stay there, because there's nowhere for them to go. Now, often you may have seen that someone might touch it. Now, if they're standing on just the ground, like this static electricity really wants to get to Earth. That's what it wants to do. It doesn't want to be there. It wants to jump back down to Earth, but there's lots of protons waiting for it. And conveniently, I've now drawn it in the wrong colour. Lots of protons waiting for it. So these electrons want to jump back down, and they will if they have a chance. And if you're touching it, then they will. Now the way you can stop this is if you stand in an insulator or an uninsulator. So in your lessons you may have stood in a box. And that means that those electrons can't get through because this is an insulator. They don't let electrons flow. So if you're stood in that box, these electrons stay where they are. And this is when your hair starts to go up on end. So this does not happen if you're in a plastic box or any other insulator, and that's when you start to feel the static electricity build up on your cell. Now, another thing you might see with this Van de Graaff generator, I'll draw it really quickly again, here, is a small metal globe, like this. And here's my belt. Now, we're building up, remember, our negative charges on the Van de Graaff, like so. Eventually, there's going to be such a difference between how many extra negatives there are on here and how many extra negatives there are on here, i.e. none, that you may see something happen. You may see a spark jump that way. Now the spark is simply a stream of electrons. And that happens when there's too many electrons build up on here and there's too few here, really. And they jump across because they don't like having lots more here than here. They want to be joined to atoms. They don't want to be on their own. And this is really similar to something you've probably seen in everyday life. This is really exactly what happens when it's thundering and lightning. So when you've got your cloud and you've got ground, during a thunderstorm, what's happening is that these electrons are building up in the cloud. They build up and they build up and they build up, and eventually they build up so much that they hate it now, and they come out as lightning. And all of these charges go through the lightning to the ground, and they go back to Earth because they want to be back at Earth, and they join the protons here on Earth. So now everything's neutral, and that's where they want to be. They want to be neutral. And that's why if you might see a church near where you live, or other tall buildings, that's quite often on churches, they may have a metal conductor, conducting wire sticking up. And that means that the electrons will jump to here first, instead of going to you, if you're stood there, quite happily. They'll go there instead of there, because that jump is much smaller and much easier. And also, it's a metal. They want to jump to metal. They prefer metal. They don't want to jump to you as much. So that's how lightning works. So, key points. Static electricity. Now, because it's electricity, that means we're talking about charged particles. Because that's what electricity always needs. And we basically are talking about electrons. Either too many or not enough. They're also static. That means they're not moving. As soon as we see that spark jump from one place to another, so from my Van de Graaff to my metal ball, or from the cloud to the ground with lightning, this now, because the electrons are moving, becomes a current. So current electricity, that means moving electrons. And we'll see why that is more important and how we use that in the next section. So hopefully, static electricity is now slightly clearer. So that's all there is really to it.